So interrupts. An interrupt is a signal. It's a digital signal sent from a device or from software to the processor. This will cause the processor to temporarily stop what it is doing and service the interrupt or answer the interrupt. So interrupts. Okay. Now the definition is an interrupt is a digital signal sent from a device or from the software to the processor. This will cause the processor to temporarily stop what it is doing and service the interrupt. Service the interrupt means do whatever that device wants it to. Now, the question is, what are the possible causes for the interrupts? So interrupts can be caused by for example, a timing signal. Timing signal which is arriving from a clock, system clock, to start the news cycle or maybe something else. That is an interrupt. So now we know that every fetch, decode, execute cycle starts with a timing signal. If there is no interrupt for that timing signal, new fetch, decode, execute cycle for the next instruction would not work. And then input or output processes. For example, a disk drive is ready to receive more data. The printer has finished printing. Someone has pressed a key over the keyboard. Someone has moved the mouse over a new, let's say, text box, something like that. Input and output processes. Thirdly, a hardware fault. Like an error has occurred, such as paper jam in the printer, or the hard disk has got some problem with it, or memory failed, or a printer is no more responding, something like that. And then user interaction. User interaction, the user pressed a key to interrupt the current process, such as Control Alt Delete, a window key, or escape key, whatever. Means which has actually caused the processor to stop doing whatever it is doing and do something else or just abort the process. And then a software error. A software error. Software error that cannot be ignored. For example, if an executable file could not be found, or the system is attempting to open a file that is not there, or an attempt to divide by zero, things like that. All right. Once the interrupt signal is received, the processor either carries on with whatever it is doing or stops to service the device or program that generated the interrupt, or stops that. So let me revise. Once the interrupt signal is received, the processor either carries on with what it was doing or stop to service the device or the program that generated the interrupt. So it is also possible, like I said, that if a teacher is teaching, someone raises the hand, that is an interrupt. Maybe more than one students have raised their hands. See, teacher might ask them to just keep quiet for some time and then it get back. Teacher gets back to them. So this is also possible that whenever an interrupt is generated, the processor stops servicing them and put them on hold or mute them. The computer needs to identify the interrupt type and also establish the level of interrupt priority. Yes, that is also possible, that computer or the processor identifies the interrupt type, that what sort of interrupt. So there are types of interrupts. Okay. Now, interrupts allow computers to carry out many tasks or to have several windows open at the same time. An example would be downloading a file from the internet at the same time as listening to the music from the computer library or the music files library. Whenever an interrupt is serviced, the status of the current task being run is saved so that processor could continue from where it is stopped earlier. So whatever the instructions that are already executed are stored somewhere, their status, their data, their registers, values, they all are stored. New interrupt has arrived, the program related to that interrupt will be actually loaded and executed. Once that interrupt is serviced or the program is executed related to that interrupt, it will be taken out of the processor and memory, and the previous program, wherever it was stopped, will be loaded again, and from the same point it will go further. So whenever an interrupt is serviced, the status of the current task being run is saved. The content of the program counter and other registers are saved in the memory. Then the interrupt service routine, ISR, is executed by loading the start address into the program counter. So the new program which needs to be executed in response to the interrupt, its first instruction will be loaded to the program counter, and that is done by ISR, interrupt service routine. Once the interrupt has been fully serviced, the status of the interrupted task is reinstated. The task which was stopped earlier and the data and the information related to that task was stored somewhere in the memory, is brought back and system continues with it. Content of the saved registers for the previous tasks are retrieved, and it continues from the point prior to the interrupt being sent. Now, so this was interrupt, but you need to go a little more further into it. Give me a second. So interrupt in computer systems in systems programming. What is system programming? When we write programs related to operating system, it is system programming. An interrupt in system programming, an interrupt is a signal to the processor it's a signal to the processor emitted by hardware or software, indicating an event that needs processor attention. So an interrupt alerts the processor to a high priority condition to a high priority condition requiring the interruption of the current process of the current process being executed. Okay. Now, I told you about interrupt service routine. In response to the interrupt, system invokes interrupt service routine or ISR, which is ISR is a software routine that processor invokes in response to an interrupt. It examines and determines how to handle the interrupt. And load the address of the first instruction of the program loaded in response to the interrupt in the program counter. In the program counter. Okay, so it's a software routine that processor invokes in response to an interrupt. It examines and determines how to handle the interrupt. Then the program which requires to handle the interrupt is loaded. And then that program's first instruction address is placed in PC so that processor now can service the interrupt or execute the program which requires the interrupt to be executed or handled. And afterwards, everything is resumed the way it was being executed beforehand. So now, as I introduced it, the interrupts, it's a general overview of the of how the computer uses interrupts to allow a computer to operate efficiently. For example, to carry out multiple multitasking and multiple tasks together. Just before we discussed, I did explain generally the whole interrupt. So now let's discuss how actually a system deals with the interrupt, specifically with the reference to fetch, decode, and execute cycle. So there is one more register called interrupt register is used in fetch, decode, execute cycle. While the CPU is in the middle of carrying out this cycle, an interrupt could occur, which will cause one of the bits in the interrupt register to change its status. For example, the initial status might be 00000000, all zeros in the register, and a fault somewhere in the hardware might occur while writing the data in the hard disk, let's say. This would cause the register to change to, let's say, 000 and then 10008. So it was earlier 0, all zeros, now it has become 8, means it has got changed. So that 8 might be indicating that this is an error related to the hard disk fault. So what will happen? That at the start of the next fetch decode execute cycle, the register will be examined. If there is an interrupt, then the content of the current program related registers value and to what particular instruction the program is executed as of yet will be stored in the RAM. New program related to the interrupt will be loaded, executed, and those instructions will be brought back from the memory and the whole thing actually continues, resumed. So let's summarize it with the help of a diagram. So let's say we have got fetch, we have got execute, and we have got interrupts together. So at fetch stage, in fetch decode execute cycle, so let's say it starts. The work is started, means fetch the next instruction. So first what you see, fetch next instruction. All right. And then we have got execute cycle, fetch and decode and execute cycle. So let's say this is execute cycle. Execute stage in fetch, decode and execute cycle. Now, what happened that we fetched the next instruction. So program started and we fetch the next instruction. Next instruction will be then decoded and execute. So it is decoded and executed. Then it checks after the decodation and execution of the current instruction whether the program is ended or not. All right, whether the program is ended or not. It is checking it after the execution of the current instruction. Let's say if it is ended, so then we will have what? End. Program is ended. Yes, it is ended. Let's say if it is not ended, then it checks are there any more interrupts where will it check? It will check in interrupt register. Sometimes you might see that they say that there is a bit of a status register which is allocated for interrupt. That is also the case. That tells that there is an interrupt, and then it goes to the interrupt register. So it checks that if there are any interrupts. So let's say there are no interrupts. If there are no interrupts, then interrupts are then disabled. Interrupts are then disabled. There are no interrupts. Afterwards, it goes back to the start. It goes back to the start. And let's say if there are interrupts, then we have got what? Interrupt stage in the cycle. So let's say there are interrupts. We move on. Yes, there are interrupts. Interrupts enabled and interrupts priorities checked. Then interrupts are enabled and their priority is checked. All right, so interrupts are enabled and their priority is checked. Okay, afterwards, it suspends the execution of current program. It suspends the execution of current program. Okay. So it goes up. What it does, it suspends the execution of current program. Now afterwards, it executes, as I told you, it loads and executes interrupt service routine. It executes interrupt service routine. Interrupt service routines examines that which program has generated the interrupt, loads that program with the help of operating system in the computer's RAM, and then loads the address of the first instruction of the program related to the interrupt in the PC. And then again, the process gets back to the fetch stage of the fetch decode execute cycle. Now, if you could see the whole thing together, this is actually fetch part, and then we have got what? Execute part. And then we have got what? Interrupts part. All right. So this is actually fetch, stage, in fetch execute cycle. What happens that it starts, it fetches the first instruction, then decode and execute it. Then it checks if the program is ended. Yes, it is ended. If program is not ended, if there is any other interrupt, then no interrupts are disabled and the program goes back to the start. If there are any interrupts, then interrupts are enabled and their priority is checked. Then it suspends the execution of the current program which is being executed, and then it loads the ISR. ISR executes, it examines, determines that which application is related to the interrupt. If it is related to the interrupt, then it is loaded. Its first instruction address will be loaded to PC so that processor could execute it and the whole thing is restarted. So we have got fetch stage, execute stage, and then interrupt stage in fetch, decode, execute cycle. We will elaborate on it tomorrow once again. All right, so that is how it works. So let me explain it once again, just this part of it. A special register called the interrupt register is used in fetch, decode, execute cycle. While the CPU is in the middle of carrying out this cycle, an interrupt could occur, which will cause one of the bits in the interrupt register to change its status. The following sequence is taken place. At the next fetch execute cycle, at the next fetch decode execute cycle, the interrupt register is checked bit by bit. The contents would indicate, let's say, an interrupt occurred during the previous cycle and it still needs servicing. The CPU would now service this interrupt or ignore it for now, depending on its priority. So you need to understand that when one fetch decode execute cycle works, while the cycle is going on from PC to MAR points, and then from that pointed address, the instruction is arrived in MDR and then goes to CIR decodes and executes it. While this whole phenomenon is being executed or is happening, there is no interruption. But since this happens so fast, in billionth of a second, we don't feel it. But while the fetch decode execute cycle is happening, interrupts are not changed, but interrupts are keep generating. So once the fetch decode execute cycle is finished, only then interrupt is checked. So when does system check about interrupts? After every completion of fetch decode execute cycle. Now let's say it's hypothesis that let's say we have got 1 billion the speed of our microprocessor is 1 gigahertz, means system can execute 1 billion instructions per second. So it means that after every instructions execution fetch decode execute cycle, the system is actually checking the interrupt. So let's say a hypothesis that for 1 gigahertz computer, the system checks 1 billion times the existence of instruction. I mean the interruption. So after every fetch decode execute cycle, system checks for the interrupt. So if it is 1 gigahertz computer, then system will check for interrupts 1 billion times. All right, once the interrupt is serviced by the CPU, it stops its current task and stores the content of its register which it has saved earlier. And then control is transferred to the interrupt handler, which is ISR. It then handles the interrupt. Once the interrupt is fully serviced, the register is reset and the content of the previous program's registers are restored. We have more to discuss about it. We will discuss tomorrow then. This is the end of this particular day in the class. So if there are any questions, please do ask. Any question? Anyone? अच्छा, अब जरा आप लोग जाने से पहले अटेंडेंस तो मार्क कीजिए. जो भी इस वक्त बैठा है कंप्यूटर के सामने वो जरा प्रेजेंट लिख दें. उसके बाद जो है ना मैं आपकी क्लास खत्म